we have draw all the resonance structures for carbonate ion, and I wish that I did not see that because now I know I only have to draw 3. But nonetheless, let's see if we could have figured out how many resonance structures it would have. So the goal here I like to do personally is just draw the best resonance structure based on its formal charges. So we're aiming for a carbonate, okay? So carbon being on the 14th column has 4 valence electrons. Oxygen, 16th column, 6 valence electrons. There's 3 of them, so that's 18 it contributes, plus the 4 from the carbon, and plus this nice 2 here because of the fact that there's 2 extra added electrons. So that is, in total, 18 plus 4 plus 2. We're dealing with 24 electrons total. So with that being said, we're going to put carbon right in the middle, and we're going to now add the oxygens. And now we're going to try to fill in the rest of the valence electrons based on what it has left. Oxygen right now is sharing 1 of its 6, so 2, 3, 4, 5, 6. Same thing here, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6. And now what I'm going to do is go ahead and add the 2, sorry, not just yet, sorry about that. Went a little too far ahead because carbon right now is sharing 3 of its 4. So we need a 4th one right there. Now what I'm going to do is go ahead and add the 2 extra electrons, one right here and one right there, just to fill in those 2 octets. And now for the last one, I'm actually just going to create a double bond here. Okay? So now we have, this would be 1 of its 3. Okay? This. And every octet rule should be filled for each one. And now let's check their formal charges to see why this would even count as a resonance structure. So for carbon, it likes to just have 4 bonds for it to have a formal charge of 0. So that carbon in the middle is perfectly content. The double bond counts as 2 bonds. For the oxygen, for it to have a formal charge of 0, it needs to have 2 bonds and 2 lone pairs. Only 1 oxygen does that. The other 2 oxygens have gone ahead to replace a bond with a lone pair. When you do that, you become more negative. You've now taken a negative step. So each oxygen here is a formal charge of -1. And as you can see, it makes sense because the whole molecule has 2 minus for its charge. This is where it's coming from. And just before we go any further, we're going to actually see if we even have 24 electrons. So we have 4 bonds right here, so that's 8 electrons. And we have 3, 6, 7, 8. So that's 8 lone pairs times 2 is 16, plus another 8, 24. Perfect. So this is one of the 3. And why am I now so confident that there's 3? Is because think of these oxygens are as separate entities. What if the middle one wants a double bond? Which is exactly, funny enough, what we're drawing. This counts as a different molecule, technically, or at least different resonance structure than the one on the left. Because now different oxygens have the formal charge of that -1. It's going to be this oxygen here, this oxygen there. This is a possible resonance structure. And now you're probably guessing, okay, then that means the last one you can draw is now when the double bond is all the way on the left now, which is what we're going to draw. Okay, this would also be a different resonance structure because now we have the formal charges on the left, on the right, and on the middle carbon. So this is now the 3 resonance structures, at least I can think of when they say they have 3, because each time the double bond is moving to a different location. Okay, so let's see what our colleague has to say in terms of the rest for this carbonate ion. Yes, so as you can see, we have the 2 minus here at the bottom, then it shifts where the double bond is now on the left, so the 2 minus is here, and now it shifts again to where now the double bond is at this bottom one here, and we have the 2 oops, looks like they may have drawn this a little bit off, because this is correct, yes, but they forgot to get rid of the minus here and the minus here, because this would not be it. I'm going to say that this is incorrect, only because it's mistakes like these, especially when you're using like a software that you're given to by like your school and stuff. It's very important to double check your work and make sure that you have gotten rid of certain signs and everything, because this is, for example, is telling me that I have CO3 3 minus, and doesn't even say where we even got the minus from, because that's a neutral formal charge. This right here is a neutral formal charge. There should not be a negative there. So it's just stressing the importance of checking over your work to make sure that your formal charges are indeed what they should be.